Okay, here's the last proof from section 2.5. We are trying to, it's actually very similar to the one that we just did. Given the diagram and the fact that AB is equal to DE and that BC is equal to CD, what we need to do is show that C is the midpoint of AE. So maybe go ahead on your own, place what would be the given and what would be the proof. So we know that the segments are equal, and we need to show that C is the midpoint. Okay, so looking at how they started the two-column proof, AB is equal to DE. That is part of our given. Easy enough, we can write given here. And then I'm going to show this on my on the picture. So AB, when tick mark is congruent or equal to DE. After that, it says that AB plus BC is equal to DE plus BC. So I would try and get in the habit of comparing this statement to this statement. What changed? You might notice that they added a BC to both sides of the equation. Since they added something to both the left and right of the equation, this is just addition, property of equality. So far, we've just been calling it addition. All right, this next one is given. Well, the only statement that is part of the given that we haven't used is that BC is equal to CD. And this looks a whole lot like, well, a mix of this and this. So I'm just going to compare them a little bit. I see that AB plus BC, that matches what's up here, is equal to DE, which also matches up there. But what changed is that BC is now equal to CD. And we actually did something similar to this in the last proof. And when you only change one small part of your statement, that is an example of substitution. Okay. So this next one, it says that AB plus BC is equal to AC. And let's just kind of double check to make sure that that makes sense. So AB, which is this segment, plus BC, which is that segment, is equal to the whole thing, AC. This is true, and this might be an example. You might even be able to compare it to something that we did in the last proof. This would be segment addition. All right, so from here we need to use the transitive property somehow. I'm going to look for the middleman. I notice that AB is kind of equal, to a lot of these statements. So maybe AB is going to be the middleman. So, and by AB, I mean AB plus BC. This has been in step 4 and step 5. So what I'm thinking is that if AB plus BC is equal to DE plus CD, and AB plus BC is also equal to AC, then what we can conclude is that these two items are equal. Use the proof to help you, especially now that they will give you little parts of it and you just kind of have to match what fills in. So AC is equal to DE plus CD, and we can kind of look at this. It says AC is equal to DE plus CD, okay? So then we also probably need to talk about some sort of segment addition property, and I'm going to use letter 5 to help me out. So we already said that AB plus BC is equal to AC. I bet we need to do that on this side as well. So DE plus CD, or DC, is equal to EC because of segment addition. All right. Next one's transitive property. If you look up at 6 and 7, compare what's going on in here, there is a middleman. You can see that DE plus CD, and I guess I should probably keep it so that it looks the same, as to not confuse you later. So DE plus CD is written here and here. So what we can do is replace the middleman and say that AC is equal to EC. Right? So that means that this segment up here is equal to this distance, or this segment right here. The next one, we need to use the congruence property. So again, it's actually really easy. I know it seems a little redundant to say it, but you know what? If it's free points, easy points, you can easily just switch out the equal sign with the congruent sign and put segments over your letters. So if AC is equal to EC, then that means that the two segments are congruent. And then that means, so if these two segments are congruent, then that means that C is in the middle of them, and it's splitting them in half. So we can conclude that C is the midpoint of the whole segment AE because of the definition of midpoint. These will be different, and like I said when we did the last section, this is a different type of math. You know, you're not solving for an unknown variable. We're just taking a bunch of statements that we know to be true and then using them to prove other statements true. Some tips that I'm just going to show down here. Label and draw a picture. Understand the problem. Like look it over and see if it makes sense to you. Try and use the given information to fill in more and try and expand on that. Make a plan. Maybe that plan would be to work backwards if you need to. And then do as much as possible. I can work with, you know, a couple of these filled in, but if it's all blank and you just say that you don't know what you're doing, I need, I guess, somewhere to start. So do your best. I believe that you can do this and work together, especially while I'm gone. See you soon. Enjoy.